Today we're going to start solving radical equations, so just equations that have a radical or square root in them. And we're going to just start with part one. Before we do, got some warm up and review for us. Number one, solve for x. Super simple. Solving for x, so get that part alone. So we need to subtract 4 from both sides, and I'm left with x squared equals 16. Now, to undo a squared exponent, you can use a square root to undo that. So I'm going to take the square root of both sides. That's going to cancel out that squared that was on the x, and I'm left with x equals, now the square root of 16, is 4, but when you use a square root as your inverse operations, we actually need to observe plus and minus. So let's make a note of that here. So this is going to be important later when we're solving those numerical square roots below. When you take the square root as your inverse operation, the result is going to be plus and minus. So I'm going to put that here. X is equal to plus or minus -4 here. Why? Because technically, if I plug in -4 back into that x, -4 squared, all of it squared. -4 times -4 is what? Positive 16. So the negative works as well if I plug it in place of x here. -4 squared is positive 16 plus 4 equals 20. And obviously then the positive value also works. So you do have two results there. Again, going to be important in the second section that we talk about in our lesson today. Number two, still reviewing and talking. If I had the square root of x plus 1 equals 4, I would need to isolate that radical first, get that square root all by itself on one side, and then 4 minus 1 is 3. To undo that square root, we could square both sides. Those are inverse operations. So when I square the square root, I just have x, and on the right side we have x equals 9. Final answer there for our review. So on the first one we looked at, if we had an exponent of a 2, we used a square root to undo it. In number 2, we had the square root, and what did we do? We squared it with that exponent to undo that. Let's look at solving multi-step literal equations that have radicals in them, or maybe you can see number 3 has a squared. We're going to use the same idea here. And if you recall, we did literal equations early on, but I usually see these come up on your benchmarks. And so just to make sure we practice these before EOC. Number 1, solve the following equation for lowercase b. And so the letters, capital, lowercase does matter here. Be mindful of that. So already that b is stuck in that radical. It's kind of locked in, right? So let's get rid of that radical. There's no other terms outside the radical on that side. I am going to square both sides to get rid of that radical. When I square that right side, that cancels out that radical. So I have u squared equals, it's broken out of the radical. We have g b minus r. So keep following your rules of equality to isolate the lowercase b. Get rid of that other term, the minus r, by adding r to the other side. On the left, u squared and r are not like terms. We can't combine them, but I can write them together on the left side. So u squared plus r equals g b. G and b are bumped up, showing multiplication. So we're going to divide the g away. And I can see the home stretch here. Final answer, lowercase b is equal to u squared plus r divided by g. Number 2, solving for capital letter G right there inside that radical. Again, there's no other terms to move over first, so we're ready to rock and roll. I'm going to take that radical of 4g minus n squared, and I'm going to square it to get rid of that radical. And what I do to one side, I got to do to the other. So we're going to square the t as well. Squaring that radical cancels it out. We have 4g minus n squared equals t squared. We are solving for capital letter G. We're at 4 and G. Get rid of the extra term, minus n squared. So let's add n squared to both sides. 4g equals t squared plus n squared. And then we're getting g by itself. It's right now has a coefficient of 4. So let me divide 4 on both sides. Final answer, g equals t squared plus n squared divided by 4. Number 3, solve the following equation for lowercase b. Stars, highlight, emphasizing, you may, you can, you will, you should. Assume that all the variables here are positive. So do not use plus or minus or absolute values. So I know I just showed you on number 1 in our review warm-up, use plus and minus. For this, they're saying, hey, we're going to assume everything is positive, so let's just stick with the positive. So on this section with the literal equations, we're not going to use plus or minus. We are in the next section. So we're solving for lowercase b here. I'm going to get rid of that extra term, the minus 4g, by adding 4g to both sides. I have db squared equals m plus 4g. Solving for lowercase b, we got to get rid of that d that is bumped up and multiplying. So dividing both sides by d, we have b squared equals m plus 4g divided by d. Next step, so trying to just get b, only a b, not a b squared. So let's get rid of that squared by taking the square root on both sides. That'll cancel out that squared. And we have final answer, lowercase b equals the square root of m plus 4g divided by d. All of that is in that radical, okay? So when you're typing it on Delta Math, you want to make sure you're making a big, big radical with the fraction all inside. All right, now is here the bulk of our lesson, what we're really getting to. This is part 1. We'll go an extra step in lesson 2 on these radical equations. It says solve the equation and check for extraneous solutions. New vocabulary here. Extraneous solutions are solutions that we solve and we get legitimately, but when we plug it back in, it actually doesn't work. So back in elementary school, middle school, wherever you first had that math teacher that said, plug it back in and check your answers, this is where it actually matters. So we're going to practice that on this lesson. It really comes into play a lot in lesson 2. So number 1, the square root of 5x minus 36 plus 1 equals 4. So the first thing you want to do is make sure that radical is all by itself. So the first thing we need to do is subtract the 1 from both sides. So the radical is isolated. So square root of 5x minus 36 equals 3. Okay, let's get rid of the radical. Let's square both sides. Squaring both sides will cancel out that radical, leaving us with just the 5x minus 36 equals 3 squared makes 9. Deep breath. This looks familiar, right? Okay, let's add 36 to both sides. This is just a 2-step equation. I have 5x equals 45. Divide both sides by 5. X equals 9. Final answer. Now, before I circle it, I'm going to check my work and make sure that this answer works. So back into the original problem, 5 times 9 minus 36, outside the radical plus 1 equals 4. In the radical, we have 45 minus 36. That's 9. The square root of 9 is 3. Back with the rest of the equation, plus 1. Is that equal to 4? Absolutely. So it does check out. Let me put question marks back up there. So use when x is 9, this equation is true. Again, practice makes perfect. Going ahead and setting that foundation of when you solve these, check, check, check. Usually we see these on benchmarks as, the multiple choice questions. It'll be like, is the answer choice 9? Is the answer choice like no solution? And so that usually clues you in like, oh, this is the type that I need to check my answer. I can solve it and get an answer, but when I plug it back in, it might not work. Okay. Number 2, same thing. We've got the square root of x minus 6, then a minus 13 equals negative 12. We need to get the radical completely alone. So when we square both sides, we're not making a giant mess. So add 13 to both sides. The square root of x minus 6 equals a positive 1. Now that the radical is by itself, square it up, square both sides there. That's going to cancel out that radical on the left side, leaving us with x minus 6 equals 1 times 1 is 1. All right. Easy little one-step equation here. Add 6 to both sides. X equals 7. Before I circle it, I'm going to check my work and make sure that this answer works. Original problem, we had X, so I'm plugging in that 7 minus 6 outside the radical minus 13 equals negative 12. So is that a true statement? In the radical, 7 minus 6 is 1. The square root of 1 is 1. Rest of equation minus 13. 1 minus 13 is negative 12. So this all does check out. 7 is a answer. Number 3, last example, isolate that radical, so add 13 to both sides. The square root of 3x minus 5 equals negative 11 plus 13 is a positive 2. I'm going to square both sides to get rid of that radical on the left side, leaving me just with the 3x minus 5. 2 squared is 4. Two-step equation to solve here. Add 5 to both sides. 3x equals 4 plus 5 is 9. 3x equals 9. Divide both sides by 3. 9 divided by 3 is 3. Let me check my work here. Original problem, we had 3x. So I'm plugging in that 3. 3 times 3 minus 5. Outside the radical, minus 13 equals negative 11. 3 times 3 is 9. Minus 5 is in my radical. 9 minus 5 is 4. The square root of 4 is 2. Minus 13 does indeed give me a negative 11. So that checked out. X equals 3 is our solution. All right, again, this is just part 1. Part 2 gets a little more crazy. We see a lot more of those extraneous solutions come in, but go ahead and be practicing that in part 1 for lesson 1 here. Plug it back in, make sure it works, because you're going to have some answers later that don't work when you plug it back in. And also we incorporated in this lesson, what if there's literal equations or formulas and we're rearranging. We're just using those inverses, square roots to undo squareds, or squareds to undo radicals that are square roots. So practice that, guys. Let me know if you have questions, and I'll see you in class.